what I want to give you today is an overview of how our firm uses Mathematica. This differs, I think, from the usual installations where Mathematica is, or maybe not the usual, but often people are using Mathematica to solve a particular problem, or it's part of a larger process. For us, Mathematica is sort of the underlying technology on everything that goes on in the firm. Anything that has to do with numbers gets run through some portion of a Mathematica application. Why did we choose to use Mathematica? Back in the late 1990s, I started a company called Investor Analytics in New York, which did risk management for hedge funds as an outsourced provider. Back then, we developed all the technology for investor analytics in Java. We developed some technologies that are sort of our own version of Java server pages before Java server pages existed. We developed our own version of Java Beans before Java Beans was developed. And one thing that we tried to use to bring all of the, or sort of a core function in all the code we developed was this concept of business objects. So that when you instantiated a Java object, you could, the risk model, all the information for that day's risk model was in that Java object, and you could query it and so on. We used Mathematica at the time, but we really used it mostly for a scratch pad, a virtual blackboard, if you will, when we were trying to create the models, or we wanted to test models, sort of as a workaround. And once we got the idea, the model the way we wanted it, we transferred it to Java. When I sold Investor Analytics in 2006, the technology world had changed a lot, and all these other new technologies were there. And in the meantime, Mathematica had introduced a couple of other features, particularly the Web Mathematica, which lets you cut and paste directly out of these notebooks like you just saw. You can take those results, cut them, paste them into a Java server page template, and the output from the model, from the Mathematica code, will show up on a web page. And to me, when we started in EQA Partners, I had a clean slate. We started the company in 2006, started trading in 2007. By the way, that's not a great time to start a hedge fund. I'm just but when we started it, I had a complete clean slate as to how to build the technology. And I didn't want to go back in and rebuild everything in Java and build, my own version of server pages and all those and so on. And looking at how Mathematica had grown in the time that we had built Investor Analytics, this just really seemed like a natural fit. Another feature I really liked about Mathematica, and this was something that we would use it for also at Investor Analytics, was this notebook structure that you see, how, as he was showing you in sort of their slideshow format here. But this very seamless way that they let you bring English, a written document, and merge that with Mathematica, with technical code and results. We would use this occasionally with our clients at Investor Analytics, where somebody had a particular question about a risk model. We could, through one of these linking softwares they talked about that links with Java, we could actually instantiate our model Java object in Mathematica and query it to get the client's data out, and then write a real narrative for them on what was happening in the model and why they were getting the output that they were getting. And we found this very useful. Our clients found this very useful. So again, when we were starting EQA, I didn't want to recreate all this technology. I really liked the Mathematica interface and how it allowed you to explain information. And so we started to build all of the functions using Mathematica. And what I'm going to show you today is sort of how we've put all these things together and give you some examples of how each person in our firm uses, in some way, Mathematica, even though there are a few people in our firm, my CIO, who doesn't even know how to turn his computer on in the morning. He's still using Mathematica. So let me start with this beautiful picture. Some of you laugh. You may have seen pictures like this because it might look like your technology setup, maybe. This was an old client of mine at Investor Analytics. This is their technology diagram showing all the different data consumers, the data producers, there's middleware layers in there, all these interprocesses to change data from one format to another, to convert units, that sort of thing. The fact that there's a big database sitting in the middle of the picture is just that, it's sitting in the middle of the picture. If you really look at this, it's not a central part of their operation. I saw a lot of this, and before I started investor analytics, I was a consultant with Deloitte, and I did a lot of sort of the data warehousing kinds of technologies, and we used to sell people on these pictures. We loved that picture that they had, and then we said, this is what you really should look like. So you put all your data producers on one side, and you put all of your consumers on the other side. And if you look like the previous diagram, then you've got sort of lines connecting all these different functions, and this is sort of an n-squared problem, right? Consultants love this because what they're going to tell you is you want a big database in the middle, and then you have an n problem as opposed to an n-squared problem. And that each consumer and each data producer only talks to the database and doesn't talk to all the other applications. That's great in theory, but unfortunately, most of the applications don't all talk the same language. They use numbers in different units. So the consultants tell you really a lot of time in building all those interfaces. So we did sort of a little bit of a hybrid on this. Instead of just talking to the database, all these functions are built using something I put in there as this IT function. This isn't something physical in this case. This is a bunch of Mathematica code. It's a very big library of code that all these applications from the data producers to the data consumers use. Any data that gets written to our database goes through this library. And almost all the data that comes out of all the data that comes out of the database comes out of this library as well, even though you may do some final processing on it afterwards. So that was sort of more of a functional diagram. Maybe this is more of an architectural diagram on how some of these technologies that you've just seen are layered together. Mathematica is what's running sort of the whole box where all the colored stuff is there in the middle. The J-Link, which is their way to connect to Java objects, we use that to talk to bank trading systems and some data providers. The JDBC database link is actually also part of Java, but we use that as our connection to a Postgres database, which holds all of the data. We don't really do any processing of data in the database. We really just use it strictly as a sort of a data store. Then there's this big Mathematica, EQA Mathematica package. This is that code that I was referring to. I showed all the little icons up here, the Mathematica Spiky and the little one with the play button in it, which is the Mathematica player, which lets you read Mathematica documents without the full Mathematica system. So this is, but it doesn't let you interact with it, but it doesn't let you sort of create Mathematica documents. So those two applications are use the EQA package directly, this big library directly. Then we've got the browsers and Microsoft Excel, and they are actually connecting to Web Mathematica, which is a Java server page link into Mathematica. And that uses sort of an additional library of a bunch of routines that will help do HTML formatting and CSS styles and stuff like that you'll see in a second. So who uses these different applications? Pretty much everybody in the firm is using some version of the web. So we have everybody, the traders, the research, fund administration, senior management, marketing, investor relations. Everyone uses the web browser some point during the day that's interacting with our data, all done through Mathematica. The next group, the Excel and the Mathematica player concept. This is sort of the medium, heavy users here. Traders, back office, marketing, investor relations type people. I mean, you all know that you can't not give traders Excel. So they all have Excel, and I'll show you a link in there earlier. When we use Excel, Excel is, when we want to give the traders data, as like, for instance, current positions and so on, model values, all of that data is actually going through a web link instead of a direct database link. So it's still going through the web, which means it's still going through that Mathematica library. And then lastly, the Mathematica application itself is used by I'm the chief risk officer, so the risk group, we use it, the research group uses it, and some of the fund administrator aspects are using it, mostly for end-of-month types of things. So now let me give you some example pages here of what this looks like. This is also our internal site. We give it to clients, a few clients who've asked for it. Using this technology, we have up-to-the-minute P&L that we give everybody in the firm and clients. We don't give clients the up-to-minute P&L, but they get everything 1 day behind. This is current positions as of a specific time during the day, and listed there for the different currency forwards. If you clicked on the New Zealand dollar one, which is clicked there, you would see down here at the bottom all of the current trades, open trades that made up that position at that time. This is sort of using a little bit of what's called AJAX in the web world, where when you click on that button, it's not really regenerating the whole page, it's just regenerating that one little portion of the page. And I'll show you some more advanced AJAX stuff we're doing later. So this is from the trading perspective. One thing I believe is you only have people enter numbers once or 0 times. You want to really cut down on input fat finger errors. So we're not a high frequency trader. The computers aren't physically doing the trading. We still have people doing that, but they trade on electronic platforms. And when they trade, we get email confirmations back from the trading platform and from the bank. Those emails go to a specific mailbox that is scanned once a minute by the system. Those emails are scanned, and then they show up in the web page here, where the trader then pulls up the trade that he just did. And if you look down here at the bottom, you can just sort of barely see the beginning. This is the actual text from the email. So Mathematica has regular expression matching and sort of text parsing functions in there. So those are all used to parse that email, and we have a template for each of the banks that we trade with. That gets parsed and fills out basically the trade ticket for them. Now, we have different accounts. We trade, the load button there, we have other managed accounts that aren't showing up on here, but they click one button to load, and that distributes the trade over all of our accounts based on the current net asset value in those accounts. And when they click book, this is not only is it entered into our database, it is then sent back to the bank. And even the emailing function in this case back to the bank is done through Mathematica because they now have a mail interface. The scanning of the mailbox is actually something that's done in Java. So our traders see a price, they click buy on their bank trading system. A couple minutes later, they get an email, they get this screen up. It's got all the information filled in. They're supposed to validate it. Click the button to do load. The bank gets the confirm back from us. Then we also use the website here throughout the day for reconciliation, where we're getting then trades back from the bank, their record later in the day, and we compare again to our trades. Volatility analysis. Another important part of this is we've tried to design the system so that there is very little static or pre-calculated data in the system. So almost every number that we present is being calculated from sort of its most raw form in the database. And we've been running for 4 years now, and we're still able to do this very fast. So what I'm showing on this page, when you click on the link to get to this page, it's going to do all of the analysis to produce all the information in here. So that's including doing full VAR models, getting all the history, for the fund, which is the FX, and then these other things are models that we run. So it's doing historic comparisons to the models. It does the track records, which I can't show, but it does those on the fly on a daily basis. So if there is some problem with a number, you go back in, it only exists in the database one place, and then the next user who needs that information based on that number, it's going to be automatically updated for them. There's going to be very little chance for them to get a static value that didn't get properly updated and to send that to a client, for instance. This is So the other screens are kind of actually a slightly older version now. The new version looks more like this, where we're using a JavaScript library that lets you do more AJAX. This is the asynchronous communication on the web. So this is actually a web page, even though it's got like a little tree view thing here going on. This is a trading ladder that matches the trading ladder coming back from the prime broker. Again, comparing our data exactly with what's with the prime broker's data. And the data, if you were using this and I was clicking on them, when I click on them, the request is made back to the web. And again, that request is filled by the Mathematica package, getting the data and processing it out of the database. Again, the traders can't take away Excel. So this is an Excel spreadsheet that they use during the day to compare model positions to actual portfolio positions. All of the underlying data that goes into this is coming from web queries. Now, you saw in the earlier presentation this concept of manipulate, which is a very efficient way of producing a very quick GUI. And this has become really very useful to us in the last year. We've really started using this more. This is a GUI screen, a manipulate screen, using data out of our system against our different models, where traders get to sort of select different blendings of models. And when they're changing these values, it's not just sort of adding up and putting them in there. It's going through and redoing an optimization every time they change it. If it needs, I mean, it's gotten, all of the covariance data, forecasted covariances, forecasted means, all of that behind it. Here's one where we're doing graphing, where they want to look at some blend of different models over some period, or during the day. I think this is an intraday one, actually. This is one that lets them look at comparisons of models back over the last few months. So now I'll just talk a little bit about how this looks from a Mathematica perspective. The first thing somebody needs to do is load this Mathematica package. That's that first little line there if you've not seen Mathematica code before. And then what I'm showing here is sort of how we've broken down some of this, how we've broken down the packages, sub-packages in here with sort of the usual kinds of things that you might want to see. Performance, package for performance. So anything that gets sent to a client, any performance number is being calculated by functions in this package. Portfolios, options, models, statistics, those kinds of things. So let me give you a little bit of an example of what I meant by sort of this business objects concept as opposed to data. I think that this is probably the hardest thing really in any sort of organization systems, is that getting good, clean data that can be easily put to use is very important. And so somebody comes to you in our firm and they say, we need you to tell us something about the current trades. And you don't have that data immediately available, but you know our database. If you're going to use our database to get that information out, you'd have to make 2 queries from 5 different tables with 5 different table join conditions. In other words, you'd have to write this, SQL. All right? And now, if we ever change the database because we want to add something or we need to do something better, something like that, then this is obsolete and you would have to go in and figure out how to rewrite it with the new database design. So the idea is to not let anybody except the people who write the package, the main core package, ever have to deal with this kind of stuff. So instead of that, you have this. You say connect to EQA, and then a little dialog box pops up and lets you authenticate to the database. And you say EQA portfolio, the name of the portfolio is example, you give the date, and you say you want trades. And this other little thing at the end is just to print it nicely as a table. So here you get some FX forwards and some futures contracts, and with all the specific details into this. Now, what we do is entirely different than what you just saw, because when all this was written, all of this that we just saw in the last presentation didn't exist yet. So this is sort of our structure for forwards and futures and so on. So you could pass the output, that's what the percent sign is doing, is passing the output from the last program into this program, or into this function. So you can say value security for that date, for the output that you just got for that date. You see the values of all the securities that were listed there, but in units of the different currencies. including the futures at the end. So you could ask our system for currency rates and request that the data be Bloomberg data, because we're getting Bloomberg data on the Bloomberg license and storing that in the system. So you have all of the currency rates there, and these little arrows mean, these are what they call replacement rules. So that says, for instance, in the first one, any place you see AUD, replace it with 0.6548, and you can tell this is old data from that. So this last one is, say, take two outputs ago and the slash dot means replace with the previous one. So what it's going to do is take this top section and replace all those currencies with those values and then evaluate. And there is the dollar value of all of the instruments that we have right now. Also, similarly, you could ask for the function EQA model, which gives you all of the model output for a particular day. So similar kinds of concepts for that date, the fundamental model, and for the example portfolio. And it returns a set of model factors. These are just internal codes for us. Expected means, expected covariance, and the weights that the model put out. You can then symbolically write out the simple value at risk implied volatility equation and apply those values to that equation, and you get the implied volatility on an annualized basis there at the bottom. Some more examples of the EQA portfolio function. Just instead of asking for trades, we have it so that you can ask it for factors. Those are the same factors that you see coming out of the model, because often you want to compare model with real life, but you don't want to have to go through all the SQL code to figure out how to do that. Or you could ask for it in positions, or you could ask for the value at risk. Obviously, these are things that are important to us and in our organization, but what I want to get across here is that all these functions are returning objects to the user that have a real business meaning and are all in a consistent set of units and organized in a consistent fashion that if you're familiar with this system, it makes it very easy to turn around and do reporting. And I think this is very important because from you're doing years of risk management for other people, I think risk managers who sort of have these standard reports that they produce every day, day in and day out, can tend to get lulled into believing that everything that they need to know is on that report. And so I felt for us that it was much more important that when the investment committee had a question, that we were able to go get data and answer that question very quickly. And the best way to do that was to sort of have all of the data essentially at hand and ready to use, and not having to go around to different systems and well, I'll go to this system to get the currency data, go to this system to get the futures data, try to bring it together, make sure that I've got days equaling days and that sort of thing. So that was sort of the main design philosophy behind how we use this here. One thing I'll just let you know, it took us about 6 months to develop this from ground zero to putting this together. It's obviously evolved since then, but within the first 6 months, we had it up and running. We were capturing all the data in the firm and using it. We had a very nice compliment paid to us by a fund of funds manager who came in. They were doing their due diligence, and their head of due diligence, this is a very high-profile fund of funds, the head of due diligence came in and said that he had often heard people talk about straight-through processing, but this was actually the first time he'd ever seen anybody do it. So I'm very proud about that, because we really have managed to sort of set a discipline and keep it. And I don't think this would have been possible, certainly would have been possible with the resources that we started with, to do this without Mathematica. And this is without any of the new math and statistics, or the finance and statistics stuff that you just saw. Just the sheer way Mathematica is structured, the ease with which it handles data from all variety of formats for inputting and outputting, and the very easy web link is really what made it possible for us to do this.